let's discuss some of the highlight and evaluation tools available in Alias. Here we have a model shaded with the Shady Sky diagnostic shader. Under the diagnostic shading map types, we have photo horizon, diffuse, double horizon, and what we started with, the Shady Sky. So these tend to show a little bit of flow in surface data, and I want to be sure that we all are discussing the tools and thinking about how the tools work in the same way. So one of the tools I see used frequently to judge what people think are highlights or reflections is the black and white bars. And it's an interesting tool. I never use the black and white bars to judge how highlights would appear on a body side, because they don't show that. When I say highlights appear on a body side, what I mean is, imagine we had a tunnel of lights, and I'll just pick this data so that we can use the center tunnel feature, and it puts the object in the center. Okay, and then we can look at what if this was a bar of light radiating in a circle. So we could scale this up, right, and make it like it was in a room full of lights. Now they're not flat across the ceiling, but they are in a circle, so they all run linear or parallel to the center line of car. And then I want to increase the number of bands so that I get a few highlights on this body side. And I'd like to show you here what happens when we look at grid line bars, or the curbing on the side of the road, or any of those features that run parallel to the center line of the street. And I wanted to show you what those would look like. Okay, and they're going to look like that. So they're going to run horizontal, right? When we look at the black and white bars in this case, in the same view, those don't run downhill in the middle of the door. So if the designer thought that a curb or the top of a building or the edge of the horizon was going to fall down as it went forward in this body side, would be incorrect. Because those lines or edges that are parallel with the center line of car are going to run true, in this case, to grid or horizontal. Not like the black and white bars run. Okay, interesting note that the ISO angle tool very closely simulates what the light tunnel shows. So the light tunnel shows lines that go basically horizontal, like this, while the ISO angle shows lines that are basically horizontal also, unlike the black and white bars that rapidly fall downhill at the front and stay parallel at the back. An interesting note would be, if we turn on this user texture and we look at Shady Sky, we could say, well, give me 4 shady skies. And you can see how those reflections actually look like. Those repeats are simply the black and white bars stacked on top of each other. All of these are. So if I switch to the photo horizon, I get a bunch of photo horizons. But the highlight line, or the shape of the highlight, mimics what the black and white bars do. Okay. The ISO angle tool, the isophote tool, which is actually identical to the ISO angle tool analysis, just a different way of showing the shading. Okay, those produce the exact same results. Okay. And the light tunnel, right? Those are your best analysis tools for how highlights will flow when those highlights run parallel to the center line of car, which most highlights do. Okay. Now they're not going to be exact, but they're going to be very close. Okay. The difference is that when we start to gun sight down these sides, we start to see some vanishing at the end of the tunnel. Where if we use ISO angle, we're not measuring, our eye isn't taken into account. So our perspective point isn't taken into account. These are just measuring an angle to a vector. And then showing every point on surface that equals that angle, okay? So let's look at another little example here with some surface data, and I wanted to show this guy, and let's set this back to 1. So we have a set of surfaces here, and I'm just going to turn on the maybe the shady sky for a second, and it looks pretty good, okay? But maybe we in the patch structure looks pretty good, but we want to diagnose how the highlights run. Someone says, well, let's use the black and white bars. And it appears that the black and white bars taper off as it goes around to the back glass or to the back end of this car. We do have some waviness up here, okay? So if we look at ISO angle here, ISO angle tends to run true and go straight to the back, different than this. And let's look at the light tunnel. Light tunnel tends to mimic what the ISO angle tool was doing back here, okay? Again, ISO angle, light tunnel, pretty good representations of one another. The light tunnel takes into effect your eye point, and the ISO angle tool does not, okay? So I tried to make some changes to this data, keeping this data exactly the same and simply modifying this data up here to true these highlights, and I came up with this set of data. So if we toggle back and forth, you can see the differences. Now we're pretty close. I don't know how far off we are, okay? But if we look at the difference between the black and white bars, okay, you can see that the black and white bars still show flow. They still show weird flow in this area, just like on both sets of data you can see. The difference between the two is that black and white shows flow, but ISO angle tries to mimic how the highlights are going to flow. Okay, different than just the flow of the surface. Okay, and one last thing I'd like to talk about curvature plots a little bit again. Let's curvature plot this data and talk about a couple things. Here we have a Gaussian curvature plot in this model. Okay, and we've got the original version, and then I modified this version here to have a little bit better curvature plot. Now in both cases we've got a low spot in here because we're trying to maintain this surface edge, and that's causing some fluctuation in this curvature plot. But really what I wanted to talk about here again with curvature plots is just to say, if this is our curvature plot, and this is a Gaussian curvature plot, what is it showing us? Well, I'll just try to draw that in really quick here. I'm going to say that that is showing us, if we looked at a section through here, okay, and then I drew the curvature plot over top of that. Well, this is tighter curvature, so I'm going to say that this is about like this. And then this is a flatter curvature plot, so I'm going to say this is about down here. This isn't quite as orange as this, so I'm going to say it's a little lower, okay? And then it looks like it's tapering off. And then I'm just going to connect those two. And I think that curvature plot is going to look like that. Okay, it's going to get flatter in here, and then it's going to get tighter or more radiused up there. Now how can we show that? Well, we've got a bookmark view right now for that. It should be right in here, right there, okay? When you draw something, it makes a bookmark. So I'm going to pick these surfaces and do an evaluation dynamic section, okay? I'm just going to rotate this around, and I want to put that section right through there, okay, and I want to rotate it, move it out here a little bit so it's going right through. Try to get it right about where that other one was. We'll go back to that view. We can rotate this a little bit. Oops. Right back to that view. Okay, rotate my section just a little bit. There. Let's move it up just a little bit. And let's turn the curvature on that. And let's up the scale here. Okay, so you can see how I was able, just by knowing what the colored curvature plot does, and the fact that it's a Gaussian, I know what this cone plot's going to look like, okay? And we should be able to do this by now, after watching that last video and this video. Now, this tells us nothing about these highlights because look how the highlights flow. The highlights flow right down this, okay? So to see highlights on a set of surfaces like this, we need to use, or to see crown in this direction, to see how that highlight's going to move, we'd need to use a tool, something like the principal maximum curvature, okay? And I'm just going to limit this down. Now this gives us a better look at how the radius transitions down here, and this is why our highlights, or in this case our black and white bars, flow down the surface like that, or the light tunnel flows down the surface like that. Let's get that light tunnel to turn on. Okay, that's why those flow down, because the principal max is correct. Okay, so that's a little bit more about reflections and the tools available in Alias.